Welcome and thank you for joining this Fluke Thermal Imaging web seminar. This session focuses on the use of thermal imagers to perform building inspections. We'll start by discussing the benefits of thermal imaging. Next, we'll take a look at how thermal imagers see problems, go into detail on their use for building inspections, as well as a preview of the SmartView software. Thermal imaging is the non-contact detection and measurement of temperature differences, and from there we assign colors based on those differences. These imagers are very effective to inspect for moisture intrusion, mold, heat or cooling loss, water and steam leaks, construction quality, to validate repairs, check electrical installations, HVAC installations, and even termite and pest detection. Thermal imaging allows you to find problems before they become visible, which oftentimes means it's too late. It's also non-intrusive or non-destructive. It allows you to scan large areas quickly and then to quickly identify specific locations. It provides visual verification and documentation of moisture problems, for instance, both before a fix and after a fix to validate the repair. It also reduces liability, improves efficiency, and can add a revenue stream to an inspection business. The image on the right shows how the Fluke IR Fusion viewing technology can help pinpoint troubled areas. This also provides a visual reference so you know exactly where the problem is. As energy costs continue to rise, the efficiency of your home becomes more and more important. By utilizing a thermal imager, you can easily spot air gaps or missing insulation, for instance. The protection of the occupant health comes into play with mold, for instance. Thermal imaging is also a major contributor to the green movement. All this adds up to saved money. As we go through the next few slides, we'll learn how thermal imagers are able to see these various problems. It is important to note that thermal imagers do not see through walls. They detect surface temperature only. Infrared is not the same as X-ray. By singling out surface temperature anomalies, or by examining the thermal pattern, we can often pinpoint where a nearby problem or issue may be. Regardless of your application, it is important to be aware of the various modes of heat transfer. The first of which is radiation. This is the transmission of electromagnetic rays through space. Every material on Earth that is above absolute zero emits infrared radiation. That's how we're able to see these things through a thermal imager. Next is conduction. This is the direct heat flow through matter. As you see in the picture to the right, because your hand is holding onto that metal rod, as it begins to heat up, the heat will travel down that rod and eventually burn your hand. And last is convection. This is the transport of heat within a gas or liquid. Think of it as a home or an office building, where cold air drops, so we place AC vents high on a wall, and warm air rises, so heating vents are placed on the floor. In this slide, we see an example of where both conduction and convection are at work. In this case, we're looking from the inside of an air-conditioned room. Outside, there is heat being conducted through the siding. Next, it is convected through the empty inside wall cavity where insulation should be. From there, it is once again conducted through the inside wallboard and then convected into an air-conditioned room. So be mindful that oftentimes more than one mode of heat transfer can come into play. You may be wondering how we're able to see moisture behind walls even though we're not able to see through the wall. We're able to do this because of what is known as evaporative cooling. When a liquid evaporates, typically into the surrounding air, it also cools an object it is in contact with. Thermal capacitance comes into play as well. This deals with a material or liquid's ability to retain its energy. Because moisture or water has a high thermal capacitance, it retains that energy much longer than other materials. This slide illustrates the point that moisture on the interior of a building is not always cold, as you may think. Here we see a water leak from a second-story washing machine. This leads to a thermal signature that is actually warmer than the surrounding wall. The level and span are adjustments that can be made right on board a thermal imager. The span refers to the highest and lowest temperature found within the measurement area or field of view. On the left we see an imager set in auto mode. Because it is automatically adjusting to the highest and lowest temperature within the field of view, it is taking into account the light that you see indicated by the red arrow. By setting this band manually, we can saturate out the extreme heat coming from the light and make a much more vivid picture. Now that we understand how the technology works, let's take a look at some of the common issues you'll likely come across when performing a building inspection. Here we see an example of where thermal imaging can be used in new construction. In the ceiling we see several areas where moisture is hiding. If the moisture is not allowed to dry before coverings are applied, there can be major issues down the road, including mold. Here's another example of moisture in ceilings. In this case, the source of the leak is actually up above where the red arrow is pointing. Because this is a vaulted ceiling, the leak is far up above and the moisture and water is actually running down the slope and pooling once it meets the wall. Here again, the fluke IR fusion is very helpful because it helps pinpoint where along this wall the moisture is pooling. Without that visual reference image, it'd be very hard to tell where that's actually happening. Here's another example of water damage within a home. The image in the upper right is of a basement that is recently flooded. Now, even though there may have only been an inch or two of actual standing water, the sheetrock and insulation has soaked up that moisture about a foot or two up the wall. By using the thermal imager, we can easily see how far up the wall we have an issue. This slide shows several examples of both interior and exterior moisture. I'd like to draw your attention to the images in the bottom right corner. Here we see a digital picture of a moisture meter being used to validate the findings with a thermal imager. Utilizing the moisture meter is common practice, and by combining that with the fluke IR fusion, you have all the visual verification you need in case of a problem. Inspection of flat and low-pitch roofs can offer huge payback if inspected regularly. Nice thing about a thermal imager is that it can inspect a large roof very quickly. And once water has entered a roof assembly, it can remain within that roof for the entire life. By finding and repairing leaks early on, huge costs can be avoided. For more information on flat and low-pitch roof inspection, please visit the session dedicated to that application. Now, since moisture has been the focus of the past few slides, I'd like to caution everyone that areas showing up cold on a thermal imager are not always the result of moisture intrusion. As you see in this picture, we're actually looking at an insulation gap. It also shows up cold, but that is because the outside temperature is so much colder than the inside temperature. It's always a good idea to utilize another tool such as a moisture meter to verify and confirm your findings. Now let's take a look at the SmartView software. The SmartView software is included with every thermal imager at no additional charge, has no license agreement or costly upgrade fees. As upgrades come out, they are available on our website. Since these imagers store all raw temperature data, there is no need to align a crosshair over the exact target you wish to get a temperature of. Every point within an image carries temperature information and can be found either on the imager itself or in the software. I'd also like to stress the importance of focus. As long as you have the focus correct when you capture the image, all kinds of corrections can be made after the fact in the software. SmartView also has a report wizard that makes it very easy to create nice professional looking reports. Here are a few sample screenshots of the SmartView software. On the left we see the image edit function within the software. This allows you to modify the temperature range, color palette, emissivity, background temperature, the IR fusion blending level, as well as add markers and text annotations. This also allows you to export images and temperature data to either Word or Excel. On the right we see 3DIR. This is a functionality of the software that allows you to view images from different perspectives. This helps to eliminate false positives and identify additional problems as well. Here you see a sample report generated by SmartView. These reports are highly customizable and very easy to put together. For more detailed information on the SmartView software and report generation, please visit the session dedicated to SmartView. And finally, we have some information on how to choose the right imager. In general, the TIR and TIR1 are meant for basic inspections and troubleshooting, and are what we consider entry-level models. On the right you see the TIR 2, 3, and 4, which tend to be used for specialized or more complex inspections as they carry a higher price tag. Fluke offers several models to choose from to fit a wide range of needs and applications. For more information, you can view the product-specific webinar. Also, please contact your local Fluke rep or distributor to learn more. There's also a product selection tool on the Fluke website that makes choosing an imager very easy as well. And don't forget about the Fluke tech support. To contact us, feel free to email thermography@fluke.com or by calling 800-760-4523. Thank you for taking the time to view this session, and please visit us at fluke.com/thermography.